Are there not enough seats? Oh, because we had 2 speakers. Okay, so I had asked at the beginning all of you to think about the generalizability question. So maybe I'll start there. So if you think about throughout the work that you've been doing, kind of maybe the main limiter to generalizability of the work that you're doing, it could be not generalizing across different users, it could be not generalizing to different placements, whatever it is. What is that in your mind limitation, and what's your approach of trying to solve for that? And then the second question that I had asked is, thinking about other papers that you have seen, are there approaches that you're utilizing that you think would be helpful to address some of those limitations that are mentioned? So let's start with that, and maybe I'll start here. We'll go right, so start with you. No? Okay, I'll start there if you want.
I think for my experience, particularly within the field of ACI, animal-computer interaction, one of the commonalities that I can draw between ACI and HCI is that it's critically important that you develop hardware and software that can actually be used in the field, and making that hardware and software as easy to use and reducing those barriers of other stakeholders in this research process to actually using your hardware and software is really critical to the generalizability. As far as other works, I definitely have a lot to learn for multimodal learning. I think that's very useful. One of the things that hasn't necessarily seen a lot of utility in the ACI community quite yet is we have very prolific IMU data, but combining video and other sources of sort of contextual information aside from wearable computers is something that seems like it could build a really big increase in the ACI field. Sorry, I kind of flipped your second question.
No worries.
Yeah, so continue on Charles' idea. For me, generalizability goes on the idea of subject variability. As all of us know, people can perform activities very differently. Like one person can perform walking, way that's very different from others. And this is a really big problem because, well, in order to have models that's generalizable to the entire population, we need a lot of training data, which we don't really have right now due to annotation costs. So again, going back to my paper for IMU data, which I believe it is one way forward, where we're extracting IMU data from either videos or a sneak peek for talk tomorrow text as well. And we're hoping that maybe this will solve the problem where there's a lack of large label data set and help build a model that's generalizable. And yeah. And as for other papers, yes, I do find a lot of them interesting, and like a lot of human activity recognition problems, and also animal recognition, and I still have a lot to learn about, and multimodal as well. And I really liked the first paper on depression detection, where there's the work on collecting this cross-domain in dataset to see, okay, are the existing method does not work so well right now, and we still have a lot of work to go on.
Yep. So context sensing. So it's a very wide field, and one of the things that keep growing in context sensing is ontologies, right? So one of the questions that we need to answer for a generalizable solution is how do you incorporate extending ontologies in a solution like Tau or any other context detection pipeline? So one of the areas that me and my Sudarshan are exploring is can we build a system that can adapt to new and upcoming ontologies over time? So that's one of the key things that we are looking forward for generalizability. To one of the other papers that I really like is Orson's paper on evaluations across multiple data sets, and I believe that it is very important that even for systems like content detection, apart from the depression or health-related thing that Orson talked about, can we actually have a generalizable solution that works across data sets and across set of activities?
Hello, yeah. So to add on to what Prasoon just said was, apart from just extending into ontology, I think context is very personalizable in a way. Like it's even if we do like extended ontology, it's more about like what do I call this particular sentence as? Like for example, on the phone call is something I want to look at it, but somebody else would want to look at it. It's like on a Zoom call or something else. It's more on the personalization side of things. Also, we were also looking into. One of the other stuff is also the fact of temporality in the nature, temporality of activity patterns in general. People perform activities in different patterns, like in a way, when you do a particular procedure, let's say in a coffee machine or something, people try to do an X task before the Y task, and so on and so forth. And people have their own patterns itself. It is going to be, for generalizability itself, capturing all of these different patterns is something would be very important. And one of the things that we was looking into is like how can we define these rules or like understand these new rules or patterns, and then hey, like ask the user like, hey, can we like label this thing as like a particular activity or a context that you would want to detect. So apart from for the other work that I've seen, I've really liked all of their work, and especially in the multimodal sensing and also the global data set. All the different variations in the mental health and everything else is pretty important. And I think we are looking forward to all of these different type of data sets that can be used to extend our work as well, hopefully making it more generalizable in the future.
Yeah, so I think maybe I can also bring in some of the insights from our global data set that we can break down into the generalizability challenge in two different categories. One, as Rana just mentioned, that is individual difference, where each people behave in a different way. And the second perspective is actually individual, like their difference over time, where the people's behavior are going to change over time. So that's where one of the reasons in our task where we're trying to do the same users generalized across different years. And both tasks is not it's not easy. So the performance is not perfect, which means both of them are source of the challenge of the generalizability. But if we compare these two type of generalizability challenge, we figured that, which is not surprising, that individual behavior difference is a bigger challenge to address than the same person across different time behavior difference. So, but again, these are two thoughts of the challenge I think with the world solving in the future work. And so yeah. And in terms of how we can further improve the performance of the model, performance of the generalizability, I think there are two general different thoughts. One is from the dataset perspective, that we collaborate across multiple institutions to bring out these multi-year datasets. That could be a good starting point. And we're welcoming an open source our code and platform to the whole community. We're hoping more research groups can contribute more data. In our current cases, they're all college students, young adults, not representative enough for the general population. So how can our technique generalize further to more different age groups, different other populations? That's a future work to answer. So that's from the dataset perspective. Another one is from the algorithm perspective, is where how we can build up, borrowing more insights from behavior science and develop better algorithms. Like this reorder is just based on the simple insights of behavior continuity, and there are definitely other insights we can leverage to build a more advanced technique to further improve performance. These are two different threads that I think would be worth pursuing in the future work. And all the other works is really interesting, really inspiring. I am the person who really can push for open source or code and data sets. So Tao has the GitHub link, which is great. And also we're looking forward to other groups to also open source, because if it's an important problem, other people should contribute and we can work on this together so that we can share and push the community in the future.
Okay, thanks. Yeah, I would like to offer another potential perspective on generalizability. So you have talked about the generalizability from the dataset perspective and so on. I think it's also interesting to think from how we are going to use those sensing technology, how we would let designers and developers to use those sensing technology like IMU, those cool stuff. They can be applied to not just you sense the context and activity and human behavior. They can be applied to a lot of application scenarios. So I think it's also interesting to consider the portability of those algorithms and technologies. Like how do we make the designers or developers quickly to adapt them and develop their own use or novel applications. And I think thinking from my own project, one potential way to improve the generalizability is to, well, so my project was sensing and tracking the assembly tasks. So there are so many kinds of assemblies, and in order for the applications to work, we need to load the models into the assemblies. And this takes time and work. So potentially, I think one inspiration probably is from global data sets, although it's completely different data sets, is to have like data sets of all those kind of assemblies and tools to be preloaded and allow developers to quickly build the application on them.
Thank you. Yeah, I think they have provided very insightful comments regarding generalizability. I wish that my student can join, but he, due to the visa issues, will not join. And I mean, as a professor sitting here, so I think it's like a kind of nervous because yeah, these young generations, they are providing very insightful comments regarding the generalizability. So I think data and the model are the two key parts that people have studied a lot. So as long as you can collect a lot of data, then you can potentially push the limit of the models. And if your model can adapt, then you can also enhance the generalizability. So I was teaching in the course, this the Introduction to Machine Learning in our University of Connecticut. So this is course is basically facing the undergraduate students. And one key problem that I try to introduce to them, I mean as an educator, is that, okay, when you train a model, you want to push the model not just by fitting over the accuracy, but instead you would like to further think about what might be the generalizability of the models. Because this is a kind of the key drawbacks of many different research nowadays. They may not be generalizable. I think besides the data part and the model part, and the third part that I'm not sure whether it has been overlooked or not, is about whether the generalizability can be tangible. So whether it can be perceived by the users, perceived by the people who are using the machine learning models. I think this is something that might be interesting, because when you have the models run in a closed environment, that is nowadays a lot of machine learning researchers have been doing. It's okay, the models, you run the benchmark, get the accuracy, but later you would like to deploy in the real world, physical world, interacting with the physical objects. There are so many uncertainties, so many noise, so many difficulties for you to apply the models, and may not be so generalizable. So that is a kind of the way that potentially as a kind of the, not only the researchers, but educators, think about a way that is providing the physical environment for you to apply the models in a real world scenarios, so that you can let the students understand better about what would be the generalizabilities. I think this is something that potentially might be useful. It's a broader impact for the students taking your courses, in the future taking the machine learning careers, and potentially helpful. So I think that is some of my comments. Yeah, thank you.
So with that, maybe let me open it up for questions. Do we have any microphones?
I would like to have some suggestions on. Is it audible? I would like to have, like, in extension to generalizability, I would like to understand your view on how the labeling or the ground truth of the data sets can be generalized, and what are you planning to? Thank you.
So the ground truth acquisition, how it can be
Yeah. Yes.
So that's a really good question. The data labeling for ground truth, yes, like if the data is collected in different environments, then generalizing models to other environments where we have not seen any data is difficult. One of the approaches that we can use is to actually have an labeling approach which works in environments, but that has some level of user burden. So one way to think about it, like kind of a sneak peek in the talk I'm going to give later, is that can you actually automate some of these processes of data labeling in situ, where you do not rely on data collected over across multiple environments, but where you are deploying your sensing mechanism or activity recognition mechanism. That's when you do it without implicating much user burden. Makes sense?
So I think in my case, in our dataset case, where we use mental health as one of the prediction tasks, which also introduce a set of the new challenge, where the mental health itself, even when working with psychiatrists, we're figuring out it's actually pretty vague to define. So currently, what we're trying to do is what we can do best is to use the most kind of standard or commonly used questionnaire like PHQ-4 or PHQ-9, BDI-2, CSED. Those are the commonly used questionnaire, the self-report questionnaire, using as a standard pre-screening tools, so that we are trying to kind of standardize across different studies so that we can have a relatively more generalizable measurement of their mental health issues. But this also opened up a new future research question of how can we better define the mental health issues. And is it only a job from psychiatrists and psychologists, or we as a UbiComp researcher can contribute by collecting more objectively measured behavior data and combined with certain of their expertise to better define the metric. But that's a future work I think will be awesome to explore in the future.
One other thing, like for example, in Tao, the context sensing project as well, like the rules that we have defined in the ontology itself is very finite. Like one of the things is like how can we get like labels in real world? How can we extend it automatically? So one of the things that we are looking to do as well is to see if we can like our other pipeline, the temporal pipeline, can identify clusters of patterns that is not part of the ontology, and then if we can ask into it, like the users, like ask them like questionnaires or like ways of saying, hey, look, there was a new pattern. What was this pattern? Can we like model it? So there's one way of like adding it or extending our existing work itself. Our hope is that our ontology is as big as it can be, and hopefully at over time it can like reduce asking these questions, and then we have mapped almost every kind of activity patterns and context itself.
Yeah, sorry, I'll be really brief. From a hardware perspective, I think I'm beginning to be a big fan of like a maximalist approach for collecting data, in that if you're going to collect the data, just collect as much of it as you can. As you're collecting it, time synchronize it, and like for instance, for my project, a probably much better way of doing it would have been to put 10 of these devices on each of these collars. So when you have one dog who may have a very particular variation in how they're doing things, but at least you get 8 or 10 variations of the positioning of the device as they're doing it that may help to replicate your data. And since it's already synchronized with all of the devices that you're using at the same time, you label it once and then you have 7 replications of that data that then you can use.
Hello, Pablo Paredes from TRI. Thank you so much. This was very interesting. My question is more from the intervention perspective. So, yeah, we've been discussing a lot about sensing, and that's really important, and context plays a role, but the intervention, maybe context is even more important because you have to really situate the intervention and know what to do. So my question is, how do we think about generating good interventions based on contextual data? Do we need to be very precise about context, or maybe we have multiple options and then let the human disambiguate what is the option, or do we have to keep collecting data like crazy? Like, I just want to be, hear some like creative options to like have interesting, good interventions that are contextually situated. Thank you.
So if I understand your question good, you are asking about what kind of intervention strategies can be successful that can be built on top of activity recognition and context. Yeah, there can be many options, and I think a lot of people have been exploring them. One of the options that I have in mind is if the intervention strategies are something that are led by users, the entire idea of self-efficacy, where you decide your own goals and the interventions are actually focusing on whether you are actually meeting the goals that you have decided for yourself. So those kind of intervention strategies can be really successful in the cases, in the case where you are trying to identify or enhance user wellness by using context. So, yeah.
Sure, I'll try to make my answer quick. I also want to provide different thoughts of how to design a better intervention technique based on top of our modeling, any of the modeling. So I want to highlight 3 of the keywords is when to intervene, what to intervene, and how to intervene. So when to intervene is the question that's more related to, oh, should we introduce just-in-time intervention based on our detection or prediction? And so this is one aspect, and there are more different aspects to explore. And what to intervene is more about, could be a design problem about the content of the intervention, the particular content you're going to deliver to the end users, and how is also another perspective of the intervention about how you're going to design your intervention in your visualizations or different perspective. And I think as a UbiComp researcher, once we are building let's say we have a perfect model, and then how this model will be able to contribute to our intervention design for these 3 perspectives, when should we involve the expertise into this process? I think these are all great questions to think, and I just want to throw this maybe like a question or thought framework out so that we can, as a researcher, can think about them from different perspectives.
Awesome. Well, let's thank the speakers again. And please remember there are posters in the back. Please go ahead and check the posters. And if we want to play the video in the front. Thank you so much.